Good afternoon, everyone, and welcome to today's webinar with Qlucore. My name is Mats Svensson, and I'm going to guide you through this short but hopefully informational webinar about some new and recently added features in the program. And I welcome you all. We've got participants from the United States, to whom I say good morning, and we've got participants from Europe, whom I say good afternoon to. Today we're going to talk about some specific new functionality, as I said, in Omics Explorer. And if we take a look at the agenda for today, it looks like this. I'm going to give a brief intro to Qlucore because some of you might be very new to the contact with our company. And I'm going to tell you a few words about who we are and what we're doing. It's going to be very brief, though. I'll spend a lot of time talking about the specific new features added to the software, the t-SNE plots, which is a really cool feature for the discovery phase of looking for sample groups in your data material. We're going to take a look at pre-filtering, which is a way of doing quality control on your samples and doing quality control on the fly while you're working with the data, instead of doing that as a pre-filtering step before you load the data into the program. We're going to say a few words about the annotation wizard, which is another cool new feature that was added in the 3.4 version. I'll spend about 10 minutes showing these three things interactively on the screen in the software for you to show what you can do with them and give you an idea of what you can apply them to. The demo section will be 10 minutes, and I'll try to keep a 5-minute Q&A session at the end if you've got further questions. As always, if you've got further questions and you come up with those after the webinar, you can always mail us at the support, and I'll give you the email address at the end. So that's the agenda for today. And when we're talking about the Qlucore company, we're talking about a success story that started about 17 years ago, where two professors at the Lund University came up with an idea. We had Professor Thoas Fioretos at the Clinical Genetics Department, who had a lot of data, had no idea about how to analyze that data. And we had Professor Fontes at the Mathematics Department, who had an idea about how to analyze it. Those ideas became a research project, and in 2007, the Qlucore company was found based on the ideas from that research project. Today, in 2018, we've got customers around the world, 2 offices, one here in Sweden and one in the US. And we're continuing to expand all the time. So this research project turned out to be a success story. And don't just take my word for that, by the way, because the success story is backed up with quite a bit of evidence, because we've got a few hundred by now references that quotes our software as one of the sources for academic papers. And as you see here, we got a few really interesting front covers, the Nature magazine, for example, which is sort of something we're proud of here, and plenty of others. All of these references are where we are quoted as one of the sources and that our software was used in a project. They are available on our homepage. So if you want references and want to find out about what other people have used our software for, you can go to our homepage and check that out. Now, our main product is Qlucore Omics Explorer, which is a fast and easy to use tool that you can use for data exploration. The big strength of this tool is that it's interactive, it's easy to use, you don't have to be a statistical expert. You can actually go from this vast sea of data to actual discovery within moments. We usually demonstrate this software to customers and take their data, and within minutes, literally, we have the data on screen and can start showing them what you can find in it. So the software is really interactive, really intuitive, and really fast to use. And what we tend to talk about when we talk about analyzing data, we want to emphasize exploration of data. We, in the exploratory phase, start looking for patterns. You start looking for groups of samples that belong together and so on. Then you go on checking quality of your exploration, for example, doing statistical tests on that, and generate new hypotheses for further research. Also, the software package contains a thorough statistical analysis tool where you can do t-tests, you can do ANOVA tests, regression analysis, and so on. And if the built-in tests aren't enough for you, we've got an open API to the R language, so you can actually extend the statistical engine with your own statistical tests written in R. There's plenty of documentation, there's plenty of plots available, so you can export your plots and use them in your publications. There's even more genetically specific data analysis. For example, the GSEA platform, which allows you to do gene set enrichment analysis, a method which is really useful for gaining more biological insight to your data. Also, one of the more recent things we've added to the software is classification and prediction, where you can build classifiers, where you can do machine learning and classify your data according to what the classifiers have found. This is a field which is expanding a lot in big data analysis today, and something that we are going to work on even more in the future. A few examples of what we support in terms of data is really any multivariate data, but typically our customers tend to use this for gene expression data, proteomics, metabolomics, all sorts of array data. We also have an extension to the software since a few years back that supports NGS-related research, where you do analysis of sequencing data. The file formats that we support are typically the Affymetrix gene chip and cell files, Agilent's files, the Geos soft files, and also aligned BAM files. But any sort of data can be read into the software by means of, for example, the Wizard, which is our specialized tool for looking at, downloading and entering data from a text file, where you can basically tell the software what your data looks like. And we're going to look at a twist of the Wizard today, by the way. Not the data wizard, but the annotation wizard. That's one of the things we're going to take a deeper look at today. I just want to mention as well, for those of you who are already customers, and for those of you who are looking at the software and doing evaluation right now, there's extensive documentation available on the homepage. There's plenty of white papers. There's the tutorial and a reference manual shipped with the software. But on the homepage, there's also films. There's also older webinars in various subjects that we have done before. So there's plenty of documentation available on the homepage. Please take a look at that if you want to have more information about a specific subject. So now to today's real agenda, the stuff that we're going to take a look at. The first thing that I'll show during the demonstration part today is something called t-SNE plots. T-distributed stochastical neighbor enrichment, I think it is. Let me check that. T-distributed stochastical net. Let me see. Let me check here. t-SNE stands for T-distributed stochastical neighbor embedding. Sorry. And t-SNE is a method that is stochastic, which means that it is somewhat chaotic in terms of the fact that if I have a start state for t-SNE and a very close but different start state, they can end up with very dissimilar end states. Although it is a stochastical algorithm, I must also state that it's not at all random, because the same preconditions will give rise to the same t-SNE plot at the end. That's very important to state. Now, what is t-SNE? Well, t-SNE is a way of analyzing your data and grouping it together so you can find clusters. And it finds clusters by doing neighbor analysis and trying to check for how many neighbors a sample has. And the beauty of the algorithm, the smart thing with the algorithm is that for practical purposes, you have only one basic control parameter, which is called perplexity. And perplexity is, to state it in layman's terms, or in simple terms, it is basically a soft measure of how many neighbors a sample has. So if a sample has 5 neighbors close to it, or most samples have about 5 neighbors close to them, then you'll end up with a perplexity of 5. That will give you a good measure of that will give you a good plot which shows the clusters in a good way. Although you have one basic control parameter, there are plenty of fine-tuning parameters available. They are described in the academic literature regarding t-SNE, and if you want to change the fine-tuning parameters, that's possible to do in the software. The nice thing with t-SNE as a tool is, however, that you can use it as a complement to scatter plotting, PCA plotting, heat map plotting, to do more things and different things in the discovery phase. For example, I tend to use t-SNE quite a lot when I'm doing PCA analysis and I'm getting stuck. It's hard for me to find any more meaning in a data set. Then you can often go to the t-SNE view of the data set and gain more information, or view the information from a different perspective. So t-SNE is a really useful tool for the discovery phase, and we'll explore that in a moment. The next thing I'm going to show today is variable pre-filtering, which is a way to perform quality control in your data by removing variables that don't fit or don't match certain criteria. That could be, for example, variables that have too many missing values. That's a good example. It could be variables that are, in too many samples, have a too large value, which indicates an error or a mistake in the experiment, for example. And the nice thing with pre-filtering is that all the data is there, but you can remove it on the fly to explore it further and see, okay, what results would I get if I remove these variables? And you can put them back again easily, instead of having to reiterate through a pre-filtering step and reloading your data. And here's the basic flow through the program. You have your raw data here, which is your raw data matrix with your samples and variables. It first goes through the basic pre-processing steps, which is thresholding, logarithming, missing value reconstruction, variable collapse. Then it goes through pre-filtering, where we remove stuff that fits or doesn't fit certain criteria. Then it goes on to the display phase, where you see the PCA plot and other things in the software. We'll see some examples of how this works and what you can use it for in a moment here. And the last thing I'm going to show today, which is only going to be a very brief demonstration, is the annotation wizard. I want to show this today because this is something that is new to the software and which can prove to be very useful. Let's say that you have a data set which you need a new annotation for, and that new annotation comes from some sort of data source. If you bring that data source, or sorry, if you bring that up as a text file, you can edit it. Then how do I add that annotation to a data set in Omics Explorer? That's what the annotation wizard can do for you. And what I'm going to show today is the sample annotation wizard. We do have 2 annotation wizards here. There's an orthogonal set of annotations for variables, which also has its own annotation wizard. It works the same way, so I'm going to show you only the sample annotation wizard today. So that's the 3 features of the software that we're going to take a look at in the coming few minutes here. And if we start with bringing Omics Explorer up on the screen, this is what meets you when you start the software. For those of you who are used to the software, you know what it looks like. For those of you who are new to it, this is the environment. So we'll start with doing an example of a t-SNE plot. So I'll start by opening the leukemia dataset, which is one of the example files shipped with the program. So I'll load the leukemia dataset here, and I'll bring it up so you'll see it nicely. I'll also adjust the color a little bit. It tends to the software defaults to a blue color, so let's set the color to blue here. We'll have a nice blue or purplish color to the samples. So what we're seeing here is a PCA plot with the samples in it. And the PCA plot is your basic plot where you start when you open the software. So this is the sample view. You can easily go between the sample and variable views. By going to the variable view here, we see the variables. And in this plot, we have about 22,000 variables, which represent the genetic expression level for the 22,000 genes that have been measured. Our sample view is a view of 132 patients, in this case, patients with child leukemia. So those are our two views, and we'll start by doing something to remove some noise from the data. So to remove noise from the data, what I want to do is a statistical operation which is called variance filtering. And variance filtering, oops, my statistics window opened on my other screen here. Variance filtering basically means that we want to remove stuff that has a too low variance, and if I start moving the variance slider here, you'll see something happening here. And what happens is that the data set transforms. The reason it does so is that we're throwing away variables with too little variance, and we're basically removing noise. And what we're doing is that we're filtering out some of the information. So now we're down to about 1,700 variables, 1,700, and we can start to see a pattern in our data here. The pattern here is we've got a group here and we've got a group here. Now that is no surprise really, because if we color these by the diagnosis that the patients had, if we go to the two main types of leukemia, or of acute lymphoblastic leukemia, we see that these correspond to a patient group with TALL and a patient group with BALL, the two main types of leukemia. But there's plenty of more information to be gathered here, because BALL is a form of leukemia that has very many subtypes. And if we look closely at the blue group here, we can see that there is at least some hints at this being a complex structure with several subgroups. However, if we take the PCA plot here and we create a second plot next to it, and we take this second plot here, let's move this to the side, take the second plot here and use the t-SNE method. I'll show you what happens here. If we go to t-SNE here, to get the t-SNE plot, you go to scatter and you select the 2D t-SNE here. There you go, the plot is blank because calculating the t-SNE plot usually takes a little bit of time. Let's set perplexity to 10, which is a measure that works fine for this data set, because approximately 10 neighbors per group, well, that sounds reasonable. Let's try it. What happens here is that we get plenty of more information. And if we color the view that we have on the left with the same coloring as we have on the right, we'll see something interesting here. Let's go to leukemia type here, and we see that the yellow group is clearly a group here as well. There's a second group, there's a third, there's a fourth, here's possibly a fifth and a sixth, and maybe there's two or one more here. It's hard to see whether this is one or two groups. It can be really difficult to see when they're so close to each other. Now, let's look at the cheat sheet again, because now we'll go to the annotation leukemia subtype and color by that. And this is the diagnosis according to the BALL subtypes. And there you go. This is the actual diagnosis of the patients. And you see that this group here, the blue one, was found perfectly by the t-SNE plot. The green one was found perfectly by the t-SNE plot. The red one, and this one was indeed one group. It was hard to see, but this one is indeed one group. These are harder. You'll have to go to more extensive analysis to separate these groups from each other. The white group is really hard to sort out from the rest. But as you see, the t-SNE plot gave me a different perspective and possibly a better way to go through my data. Compared to the PCA plot to the right, we have sort of a hint at there being other groups. But if we color the PCA plot in the same way as we colored the t-SNE plot, we'll see that it is indeed really hard to discern the groups. There's hints at the groups, but it's much easier to see in the t-SNE, which clusters them together. So there you go. That's one feature you can use, the t-SNE plot available in the software. Now let's do something else. Let's go to the variable pre-filtering and show you that. This is another feature that was added in the latest version, 3.4, of the Omics Explorer software. And the variable pre-filtering allows you to do removal of variables. Let's open the other example dataset, this one, Qlucore test dataset, which is a smaller dataset. This dataset is only 12 samples, and if we go to the method tab here and select the variable view, it's only 50 variables as well. So this is really a small demonstration dataset, but it's useful to demonstrate what we're going to do now. Okay, let's say that we want to analyze our data, but we want to remove all variables which have missing values, where we want to remove everything where there's missing values for a sample and discard that. Here to the left in the data tab, there's the pre-filters section, and the pre-filter section has this button here, set, which brings up the pre-filters dialog, where I can decide what to do. Now, I said I wanted to remove any variables with more than, well, any missing values. So anything with more than 0% missing values, which is anything with missing values, will be removed. If we look at the bottom here, there's 50 variables at the moment. So I'll check that. Okay, let's remove anything with missing variables. What now? Nothing happened. Well, that is due to the fact that pre-filters is a toggleable effect, so you can remove it or you can switch it on and off, and by default it's off. I just set the pre-filter, but I haven't applied it yet. If I press on here, it is applied. And you see now we have 47 variables and the data view changed here. So 3 variables were removed by the pre-filtering. There's plenty more that you can do with the pre-filtering algorithm. I'll just walk through them. I'll not show them right now. You can remove variables that are less than a certain threshold. You can remove variables that are greater than a certain threshold. You can remove variables with more missing values in a certain sample annotation, and so on. You can also actually, these are grayed out at the moment, you can actually remove variables on criteria if the annotation is numerical. For example, if you have a variable annotation which is purely numerical, you can use these steps to further enhance your filtering. And all of these filters are combined, so you can do a complex filter where you remove variables below a certain value, above a certain value, with missing values, and so on. And the nice thing here is that you can toggle between your raw data view, which is with pre-filters off, and pre-filters on, just like that. Really useful for data analysis where you know that, for example, certain arrays or sequencing machines will output a certain value for an error. For example, will output 9999 where there is no available data. And you know that, so you can just say that, okay, any value above 9998, throw that away. So you get your bad values sorted out from your data. Useful, and useful especially where you have large sets of data where you inevitably get these measurement errors from your machines. That was the second feature for today, and today's third feature is the annotation wizard. So let's keep this data set here and go to our samples view here. our sample annotations that we have available for this data set are age, gender, gender pairs, sample ID, and treatment. So gender, of course, contains male and female. Age is the data distributed in age groups, for example. Now, let's say that I want to add a new annotation to this data set. I could do that in various ways, but let's say that I have a text file containing the annotation I want to edit. And let's bring up such a text file as an example. This text file has been input to Excel, and it's an ordinary tab-separated text file, so it will end up in the columns in Excel in this way. So what I have here is a list of the sample IDs. In this case, the sample IDs I have in my data set, and a new annotation I want to add called color, where I have various values that I have gotten from somewhere. I want to add this to my data set, and I want to add it according to this annotation here on the left. And that's what you use the sample annotation wizard for. And the annotation wizard is available under File, Import, Sample Annotations via Wizard. This will bring up the wizard and guide you through the various steps here. So if I select my sample annotation here, you'll get a guiding step by step here. Let's skip the first one here. It will first ask you how your data is separated. In this case, it's separated by tab characters, and it assumes the tab character by default, so I won't have to do anything here. If it was separated by semicolons or commas, I could select that as well. Or if you have your own separation character, which is different from these, you can also add that. But actually, it defaults to the tab, and that's what we had, so we'll stick to that. So now we've told the software how to interpret that. The second thing, it asks us, the annotation information is organized in rows or columns. Well, it is rows in our case, so we'll keep that. But you could also have a transposed matrix where this was put on the end, so to speak, so you have the data in columns instead. That's perfectly fine as well. It asks us what identifier to use, and I'll tell it to use this one here, because this identifies our samples. So that one is selected. And the next thing to select is what annotations to add. And in this case, I only have one. That's the color here. I'll press finish, and what happens now is that this annotation will be imported to Qlucore and put on the samples according to the first column here. There we go. Not very much happened what we could see, but if we go to the color in the annotation view here, we got a color annotation now, and we got the values blue and red. Now it automatically assigns colors here, so I should probably fix that by assigning a bluish color to this one and a reddish color to this one, so it looks good. But the colors are automatically assigned. So there we go. We got our new annotation for color, and since it's a new annotation and we actually do have it as an annotation now, we could go to the sample view and color by the annotation color. There you go. You got a new annotation in your data set that was imported through the wizard. Can be very useful if you want to add extra information. If you got extra information that is applicable to your data set from external analysis or from a database and things like that. So that's 3 little features that are pretty new to Omics Explorer and that are available to you all, and which not all of our customers know about because they are new, as I said. That being said, let's go back to the presentation for a moment here. Now, is there anyone who's got any questions about the things I showed today? If you do, you can type the question in the chat, And also, if you come up with a question later on, or if you try these things out and you run into some sort of issue and want to ask a question, don't feel afraid to just mail us, because we're available at support@qlucore.com. We offer full support also for customers with an evaluation license where you're trying the software out, because we believe that to gain full knowledge of our software, you should have support even when you are not a paying customer yet. So it's really important to us to get our customers up to speed and working with the software. Anyone with a question? No one? Well, I hope this was useful to you all, and that you learned a little bit new, or that you got a new perspective on the software today in some ways, and it was useful to some of you at least. Okay, thank you very much for today, and see you next time.